Balancing equations part 2. When we get into a little more difficult balance equations to balance, we have to figure out sometimes in what order we balance our atoms. You can just move from left to right if you prefer, but sometimes there's easier ways to look at it. Any elements that appear only one time on each side, so for example here you've got oxygen on one side here and oxygen on the other side here. If you start with those, typically they are the most complicated, so those are the ones that you want to do first. The ones you want to save later are the ones that appear more than one time. So here you can see there's some lead, and then there's some lead in the lead oxide here, the lead 4 oxide. So you want to save those. And then the last thing you want to save is if you only have an element that is uncombined. So for example here hydrogen's by itself and so is lead. Those are the easiest to balance. So here we would do oxygen first, then hydrogen, and then lead. So how can balancing be affected? By the order that you use. So here we're going to look at oxygen first. There's 2 on one side, 1 on the other. Hydrogen, there's 1 on one side, 2 on the other. And then here we've got 2 lead and only 1 lead on the product side. So here, if we do our oxygen first, we can see that we need to add a coefficient here. There's 2 on the reactant side, we need 2 here. So if you put a 2 in front, you're going to get 2 oxygen atoms here. You're also going to get 4 hydrogen atoms because you have 2 water molecules, so 2 times 2 gives us 4. So it's going to change both of those. Now we have to go over to the reactant side. We could put a 4 here to balance out our hydrogens on the other side. Now if we look at our lead, we've got 2 lead here and we've only got 1 on this side, so we would add 2 here for our coefficient, and that would balance out our leads. And that was fairly simple, an easy way to get that to balance. If we do it in a different order, you can see here that it can be a little more confusing. Hydrogen, we've got 1 on the reactant side, 2 on the product side. Oxygen, 2 on the reactant side, 1 on the product side. And then lead, 2 on the reactant side, 1 on the product side. So if we look at the hydrogens first this time and put a 2 here for our coefficient, now we're balanced for our hydrogens on each side. But if we now look at our oxygen, to get our oxygen balanced, there's 2 here. We have to put a 2 here to balance our oxygen. So now we no longer have 2 hydrogen. So we're going to have to go back and change that. And if you look, we're no longer balanced. There's 4 hydrogen here, but we only have 2 here. So now we have to go back and change this again. So we have to be very careful in the order that we do this so that we don't miss that and go back and double check. And then our lead are 2 and 2 like we did before. So again, be real careful if you have to change a coefficient, if you do them out of order, that you have to go back and double check that. Okay, we also have polyatomic ions in some of when we balance equations, and there's an easy way to be able to do this. Again, we can make a table of elements. We can also include then our polyatomic ions. We can keep those all together. So if there's a phosphate on the reactant side and a phosphate on the product side, we can just leave it as PO4 and count how many PO4 we have. So here we're going to look at our hydrogens. Okay, if we want to rewrite our water as HOH, that will make it easier for us too because we have an OH here and now we have an OH here. And so we could now put OH down here in our chart. So a lot of times it's easier to rewrite your water that way. So we look at our hydrogens. We've got 3 on the reactant side, 1 on the product side because this part here is now an OH. PO4s, we have 1 on this side and we have 2 because there's a 2 outside the parentheses right here. We have 2 on the product side. 1 calcium on the reactant, 3 on the product. And then we can now look at our OHs. We've got 2 OHs since there's a subscript 2 here, and we have 1 OH on the product side. So now we can go back and add in our coefficients. So if we have 3 here for our hydrogen, we're going to have to put a 3 by our water to be able to get that to balance out. Oh, I'm sorry, I did that out of order. we have to put a 2, we're going to do our PO4s first, I apologize. So we're going to put a 2 here to get our PO4 balanced on this side and this side. And now we have 2 PO4 on each side. When we did that, we now have 6 hydrogen. So we need to put a 6 on this side to balance our hydrogen. See, I just did it out of order and I goofed up. So now we go back, start again. We want to look at our polyatomic ion first because it's on both sides. So we put a 2 here to balance out our PO4, a 2 here to balance out our PO4. Then that gives us 6 hydrogen. So we go back over here and put a 6, so we get 6 hydrogen on this side. Now we want to look at our calcium and our OHs. So here we've got 6 OHs because we put the 6 in front. So over here we're going to have to put a 3 to get 6 OHs on the other side. Now we have 3 calcium, so we go over here and we have 3 calcium, so we would put a 1 for that coefficient, and we now have a balanced equation. So let's do a couple more practice problems real quick here. We've got our polyatomic ions, OH here, so we would want to rewrite our water HOH. So that we can have a hydroxide on both sides. Okay, and we'll go ahead and do that. We look here, what do we have on both sides? We have calcium on both sides, we have chlorine on both sides, we have OH on both sides, and we have hydrogens on each side. Okay, so if you would like to do the chart, you can draw out the chart. If you don't, you can look here and see that you have 2 OHs. If we put a 2 here, we would then have 2 OHs on this side. Okay, so again, if we make this HOH, we now have 2 H's and we have 2 OHs. So if we go over here and put a 2 here, we now have 2 hydrogens on this side, 2 hydrogens on this side, 2 chlorine here, 2 chlorine here. We have 2 OHs we already talked about and 2 OHs here, so the only thing we haven't looked at is calcium. We have 1 calcium and 1 calcium, so this is now a balanced equation. Okay, so this can, whoops, excuse me. Okay, that showed you exactly what we just did. Next practice problem. Here we have hydrogen and oxygen making water. So if we look again, we can see here we have 2 hydrogen here and 2 here. We have 2 oxygen here, but only 1 here. So we have to add a coefficient here, which gives us 2 oxygen and 2 oxygen, but it also changes our hydrogen. We now have 4 hydrogen here, so we have to put a 2 here to get our 4 hydrogen on that side. And again, that's what we get for our answer. Third practice problem here, we've got iron and oxygen. Here's a little trickier. Oxygen here, we have 2 on this side and 3 on this side, so we have to find our least common multiple. So 2 and 3 both go into 6. So we want to put our 2 here to get 6 oxygen on this side, and our 3 here to get 6 oxygen on this side. So then we have 4 iron on this side, so we have to put a coefficient of 4 on that side, and that balances out that equation. And that's the end of our balancing equation.